Greetings, Davies Chem Department. We're going to look into the ionic, covalent, and metallic lab classifying substances. So to start us out, we're going to be looking at, do substances conduct electricity? Do they dissolve? Do they conduct electricity once they dissolve, to kind of determine if they're ionic, covalent, or metallic compounds? So for one of the parts, we're going to be using the conductivity meter. So I want to make sure it's on, and what we're going to be doing is just testing it first off in our distilled water. Now the distilled water is going to be our control, so if it conducts electricity, it does slightly with our distilled water, so it's going to have kind of a little bit of a positive reading potentially, where it kind of faintly comes on. If it kind of faintly comes on, we're going to say that that's still not conducting electricity. That's going to be our control, so we want a brighter light than there from that if it is conducting electricity. So our first step, wipe that off each time. Our first step is going to be look to see if our substances do conduct electricity or not. So our first substance is a solid salt sitting there. You can see that no conductivity is happening. Sand, silicon dioxide, SiO2. No conducting is happening. Paraffin wax. No conducting is happening. Calcium chloride. No conducting is happening. Our copper wire, if I can take and touch it to the sides, you can see that we've got conducting happening. Copper sulfate, no conducting. Aluminum foil, conducting happening. And sucrose or table sugar, no conducting happening. So that completes our first chart on our table. Now we'll go back to see if they dissolve. All right, so in that first part, only our aluminum and copper are the only two that conduct electricity. Now to look at if they will dissolve in distilled water. So we'll start out adding a little bit of water and giving it a little stir. And we can notice that some of those crystals are actually dissolving or disappearing into the water. Each time I'll kind of wipe off. So as we move to that sand, silicon dioxide, if we stir, we can see that grit is just staying in the bottom and nothing is happening to those ones. So not dissolving. The wax, it will dissolve. All the wax seems to be staying in place and intact, no dissolving occurring there. Some calcium chloride or sidewalk salt. Right away, as soon as we put that in, you can begin to see it dissolve and to break apart to smaller pieces, so dissolving. Copper wire, just sitting there, nothing's happening to it. The copper sulfate, as we start to mix in, you can see it starting to clump up or break apart. Over the next moments or so, you can begin to see the water start to turn blue, showing our signs that we're having dissolving taking place there. The aluminum, water just sitting with there, no dissolving occurring there. And our sucrose, we can begin to see those crystals disappearing and dissolving into the water. All right, so looking through, we saw that substance A, the sodium chloride, dissolved in water. D, the calcium chloride, dissolved in water. The copper sulfate F, and H, the sucrose, all dissolved in water. So now from there, we're going to test, after it dissolved, did they conduct electricity or not? So as we put the probe in, we want to see bright red light and green light showing conductivity is occurring in that one. See that in silicon dioxide, that we're seeing no conductivity occurring in there. Our paraffin wax, no conductivity occurring in there. Sidewalk salt, conductivity occurring in there. The copper wire, copper didn't dissolve, so we actually don't have to test to see if it conducted or not. Copper sulfate, or copper 2 sulfate, conductivity occurring in there. Our aluminum didn't dissolve, so we don't have to worry about conductivity. Sucrose, no conductivity occurring in there. All right, so now we're going to use the hot plate, to check on melting points. So we're just going to look at relative melting points. Are they kind of high or low? What's going on with them? Now remember, water is a liquid, so it's already melted. So it's kind of a trick question, low melting point for water there. So our first one was we have 5 substances in the container, plus the container itself would be the 6th substance. And as we let it sit there, we can see that really no changes are occurring between any of them in there. They just kind of are just sitting there. So we're not seeing any melting occurring. So all of these ones have high melting points. So we'll go through and see what they are in just a minute. The other ones we've got 2 more substances that right away, as soon as they're put on the melting plate, begin to change. One of them is already a liquid, and then the other one is beginning to start to change into a liquid also. It might take an extra moment as we kind of convince it to move across a little bit there. There we go. Not only will it become a liquid, but if we wait too long, we'll actually see it to begin to form kind of a light caramel brownish color. In cooking class, we know it to be caramelizing. So we'll see if we can get to caramelize but not burn. So we're beginning to see a light orange golden color there. If we let it sit too long, it'll burn. So we're going to take these off. Both of these ones are known to have low melting points. As we let it cool, you can actually see the wax come back to be a solid. With that low melting point, we could even cheat real quick and bring it back onto the hot plate. Quickly melt, remove from the heat, and quickly turn back to the solid. All right, so to conclude here, much of our substances did not melt, so remain the same. On the other side, we had our wax melt and our sugar melt. So for there, C, low melting point, and H, low melting point. The rest of them had high melting points. So make sure you're completing the chart by showing the ones that did not fit those categories. So we can use those properties now to determine on the back side what substances had ionic properties, covalent properties, metallic properties, and what substances do you believe fit into each category. Safe travels to everyone.